Now we will have a quick code demo for these different kind of neurons and the cost function. We'll try to plot them with net inputs and the activation outputs to see what kind of shape we are getting individually for sigmoid, tanh, ReLU, and what kind of behavioral things we are getting for quadratic functions and cross entropy. Okay, all right, so let's jump into our Jupyter notebook and let's write our first code demo. All right, so let's write our first code demo. Okay, I am naming it as neurons. All right, so what we are going to do, we are going to import some dependent modules first. I'm importing NumPy, then I'm importing matplot lib pyplot as plot. Okay. All right, so and now what we are going to do, we are going to create some uniform numbers between -10 and +10 with interval of 0.01, and we'll consider them as net input. Okay, net input z equal to numpy dot range between -10 and 10 with interval 0.01. all right, so what it is going to create our input variables. Now what we're going to do, we're going to define our first kind of neuron activation function, that is called sigmoid. Okay, sigmoid, it will take one input. All right, and it will return the value 1 by 1 plus numpy exponential of -1 into z. Sorry, it's x. Okay, so if you remember the equation for this sigmoid, that was 1 by 1 plus e to the power minus x. Right, this is exactly doing the same thing. We have defined the function. Now here we can quickly see a couple of things. Alright, this is our g has this many values, and sigmoid of c will also give these values. Now what we are going to do, we are going to plot them using our matplot library. Alright, so plot z versus sigmoid of z. All right, and so this is going to create a curve like this. Okay, and if we add some vertical lines and horizontal lines, adding some horizontal line at 0, starting from -10 to 10, line style equal to dotted, and color equal to make it green. This should be fine. And one more line, add 1. Alright, so let's see. Oh, my bad. Alright, similar to these, I'm going to add one more line here for your reference, one more vertical line. Add 0 between 0 and 1, line style same dot, and I'm going to make it as red. Alright, so you can see here, when the values will reach toward -5, it will start going upward from 0, then gradually it will go upward and it will reach to 1 when the values will reach to somewhere around 5, +5. So if you take this way, like the more positive value it will go, it will become 1, and the more negative values it will have, it will become 0. This way, this is kind of shape will come into picture. Okay, so next function which we are going to write is tang. Okay, alright, it will also take similar input, but the equation will be a little different. Okay, so what was the equations? It was 1 numpy exponential z minus, z will not come here, minus numpy exponential -1 into x divided by numpy exponential x plus numpy dot exponential of -1 into x. Alright, so this is the output for tang function. Okay, the other equation was 1 minus e to the power minus 2x divided by 1 plus e to the power minus 2x. That will also give the same result. Okay, now what I'm going to do, I'm going to copy the same content here, and I will only change the function, that is tang. Alright, let's see how it works. Okay, here we can see that the minimum value from this activation function output is -1, and the maximum value from this activation function is +1. Okay, so I need to adjust a little bit all these reference lines. Okay, for example, the vertical line, it should go from -1 to +1. Okay, and we need to add one more line, horizontal line, that will be at -1, and it will have the same features like these +1, 0 lines. All right, okay, I'll draw the graph once again. Now we can see the curve will go up sharply starting from -2.5, somewhere close to that, and it will go from -1 to +1. Alright, this is what the output from the activation function from that particular neuron where you are using tang as activation function. Okay, now next function I'm going to write is ReLU. Alright, let's see what ReLU does. Okay, it will take one input as x and it will return a very simple content, that is numpy dot maximum of x or 0. Alright, so okay, so for reference, again we are going to use the same context. We are going to change the function as ReLU, but in this particular case, these vertical lines will not help too much. Okay, what we are going to do, we are going to remove these to context and -1 to 10. Let's see how it works. All right, so here you can see that the ReLU is only considering 0 if the values from the net input is less than 0, and when it is crossing 0, then it will take the original net input values. So it is going up like this. Okay, it is not confined with that boundary between -1 and +1, what happened for tanh, or between 0 and 1, what happened for sigmoid. Okay, there are different other flavors of ReLU as well. So what happens, I'm just writing down the function if you want to refer it somewhere. So this is the definition for leaky ReLU. Okay, you remember I told about leaky ReLU. What happens here? Here we have a very small percentage of the negative values are considered rather than cutting all of them to 0. Okay, and in this particular case, in the place of 0, you will see very minor negative values in case the values are lesser than 0. Okay, so if I try to plot it, you will not see too much difference, but actually the values are you will see less than 0 values as well. Okay, all right, so we may not use this particular activation function too much, but this is for your understanding point of view. Now let's review like whatever I'm saying, whether there is actually anything lesser than 0 or not. Okay, you can see it here. The negative values are there. Those are very big negative values. Okay, very minor negative values. And if you take the corresponding what you call ReLU values, you will see all these contexts have become 0 in this particular case. All right, so these are the different kind of neurons, and so for sigmoid you have a S-like curve between 0 and 1. For tanh you will have a again sharp S-like curve between -1 and 1, and for ReLU it is like elbows kind of shape. It is going up from the point 0, and for leaky ReLU or parameterized ReLU, the curve will start a little lower than 0 depending on your requirements. Okay, so by this time you have complete idea about all these different kind of neurons. Okay, so next thing we are going to try is the cost function. These two cost functions, whatever we discussed, that quadratic cost function and cross entropy function. So what we are going to do, we are going to we are going to do a tally, like how those cost values are getting calculated and what kind of cost values we are getting. Okay, all right.